we saw that a signal can be captured by a shell program and then a corresponding service routine can be executed. Now, we also saw how to handle these signals using the trap command. So, we saw that these signals can be ignored by putting a return statement, and there is also another formal way of doing it, okay, which we will see in this session. So, there are two methods of ignoring signals. The actually we could consider it as three methods. Okay. The first method we saw by that in this last session, that by putting a return statement in the signal handling routine, we will be able to take action on the signal or we can just ignore it. The other ways of doing it is something like this: you can put a trap and then give a null and then give the list of signals for which you do not want any action to be taken, or you can put a colon symbol after the trap command and then ignore whatever signals you want to ignore. So, why do we need to ignore signals? So, as I discussed in the previous class, if you are doing certain critical operations, okay, for example, you are copying one file from one location to another location and you do not want a user to interrupt while you are copying the files between these two locations. So, in that case what you can do is you can disable all the signals from the particular for the user. So, like you put trap space colon space and then you give all the signal numbers, because of which the any signal that is generated to and sent to this process will actually be ignored by the process. Now, here is an example. Okay. So, in this case what we are trying to do is we are trying to ignore signals 1, 2, 3 and 15, okay, using the trap and then using the first syntax, and then we are trying to do whatever important stuff we want to do in the shell scripting, and then finally we are just then enabling these trap again back by putting trap and then you can put the function name, or you can just put trap and then you can give these numbers, and so because of which you will be able to enable the signals back. Now, let us look at it with an example. We will take the same example what we had done last time. We will take a minor change to the code and then we will see how this trap signal can be enabled as well as disabled. So, let us go to this program called a trapinfinite.sh. So, this program is the same. If you see, I am not going to repeat this again. The only change that I have done to this program is the following line. See, I have added an if statement which tells you that when you are counting down in this program, until you count your count is greater than 26, if I send signal number 15, you just have to ignore it. So, if you look at line number 23, I am just saying that if I send signal number 15, then use this trap command to ignore the signal. So, what is going to happen is until the count is 26, if you send the kill space minus s then 15 and then this process ID, the kill command, the kill signal 15, this process will simply not bother about it. Then after the number is less than 25, what happens is that here in this case, now whenever I type 15, okay, signal number 15, it will now call this process. So, this is going to print you I am ignoring you because you send me a kill signal. Okay. So, something like this I will do, but in this case let us also add the return statement. So, we know this guy is getting ignored. So, now let us run this program. Okay. So, trapinfinite.sh and then we have to give a number. So, let me give a number like say 50 and then I will run it in the background. Now, I got the process ID 14952. So, I will now try to kill minus s 14 15 14952. Okay. So, nothing is happening because until, if you remember, until 25 this guy will ignore whatever you send. Now, let the count be less than 25. So, now it has become 25. So, now I will try to send the signal. So, now it says I am ignoring you because you send me a kill signal. Now, let us move on to another facility of shell scripting. So, what we will do is we will now talk about subshells. So, essentially until now we have been handling one shell. Okay. Now, the question is how do I create other shell within a shell. So, in this case what it is called as a subshell. Okay. So, a subshell actually has a parent child relationship with its parent shell, okay, and a parent can create many subshells inside itself, and there is an inheritance relationship that comes between the parent shell and the subshell that you are creating. So, in an inheritance relationship, what are all the elements that are carried over from the parent to the child. So, in our shells and subshells, the inheritance relationship carries over one, the current directory where the program is getting executed, and then all the environmental variables that was supplied by the parent to the current subshell. Then you have any open file descriptors other than standard input, standard output and errors, they are by default they are just passed on to the child. And one of the most important things is the signals that are ignored are also passed on to the child. Okay. So, in the previous session, the session before we just found out how to handle these signals, and even the current sessions few minutes back we discussed how signals can be ignored. Now, the items that are not ignored. So, let us try to find out the items that are not ignored. Okay, the first item that are not ignored are the shell variables. Okay, so, except environmental variables, okay, other shell variables are not ignored. Okay, and so, the handling of signals that are not ignored. So, you have to find out what are all the inheritance that gets and that are not got. So, into handling of signals that are not ignored are also not got. Okay. Now, what is the use of subshells? Okay. One of the advantages of using a subshell is that you can run programs in parallel. So, what I can do is I can go on executing a shell script, and then I can spawn some subshells, and then they can be doing their job, and then I can also have some sort of inter-process communication that can be handled between. So, I think we discussed about it a lot in previous section. Okay. So, one of the things that we need to understand about subshells is that you need not write a separate script for a subshell. So, actually if you want to create a subshell within a parent shell, you essentially what you have to do is you have to put a brace like this, the curved brace. So, here is an example. So, when I say echo hello world, what it actually does is that this hello world program actually runs within a shell within the from the parenthesis. So, the code inside the parenthesis will run as a separate process. This is usually less efficient than a command block. Okay. So, if you remember the command block we had used this symbol. Okay. So, the one that is at the bottom, the curly braces. So, that was what is used as a command block. Okay. And for a subshell we use this. In a command block the process runs in the ID of the parent shell itself, but in a subshell it actually creates a new process. Okay. So, let us take a look at the example of subshell.sh and then see how we can do it. Okay. So, here is subshell.sh. So, let us try to understand this program first. Okay. So, wantedly I have not formatted the program. So, I just wanted to show you that okay, you can write a nice looking shell program as well as a program that looks like this, okay, which looks slightly difficult to understand because the indentation is bad and things like that. Okay. So, let us try to understand this program. So, as usual line number 1 tells you that you have to use the bash shell, and then we come to line number 2 where you declare a variable called an outer variable and then initialize it to the value called outer. Okay. I think this is straightforward. Now, look at these lines 4, 5, 6, 7 and 8. What this line tells you is that I have to create an inner subshell. So, this is what it says by putting this. So, inner subshell, and then inside this inner subshell I just declare a variable called inner variable, and I put the value of inner to it, and then what I do is I echo inside the subshell I put this inner variable and then find out the value of the inner variable. So, if dollar inner variable should actually print inner capital INNER, and then I am also trying to print the value of the outer variable to find out whether the outer variable is actually passed, because this guy is going to be executed in a separate process ID. I just want to see whether this value is getting passed to the subshell, okay. And then the parent shell goes on executing this. If it finds out that the inner variable value is null, then it says that inner variable is undefined, okay, in the main body of the shell, and otherwise it says inner variable is defined in the main body of the shell, because we just have to find out whether this inner variable is getting exported to the our parent, okay. So, we saw that inheritance, whatever is the parent goes to the child, but whether the one from the child that goes to the parent. So, we need to find out that, and then so after this I say from main body of shell I am trying to print the inner variable. So, let us see what happens because of the usage of this subshell. So, let us run this program and try to understand. So, what I am trying to do is I am trying to execute this program called subshell.sh. So, if you look at this, okay, the results is very surprising, but as we had discussed, for us it is not surprising. So, what it says is that if the subshell, okay, it says the inner variable is actually defined. So, I am getting inner. Similarly, because the parent is calling the subshell, it is passing its variable to the child. Therefore, the subshell outer variable is also defined, okay. Now, if we are looking at the execution of the parent says that the inner variable is undefined in the main body of the shell, but in the main body of the shell there is no variable called inner variable and the value is undefined. So, if you look at the program again, we will understand what is happening. So, if you look at this, we see that this inner variable. So, let me, instead of saying inner variable outer variable, why do not we substitute some values and see. So, I will say I will give a value of 100 to this, okay, and let me give a value of, I will give a value of 100 to this, then the outer variable I will give a value of 2000. So, you can see that the value of 2000 gets passed to the child, but the value of 100 does not get passed to the parent. So, if you run this program again, so if you look at this, the subshell gets a value of 100 as well as 2000, whereas the parent shell does not get the value of 100. Okay. So, in this way we are able to see that a subshell gets created and we can use subshells. Now, as I told you, I leave it as an exercise for you to identify the difference between using this parenthesis and using this base. So, what you do is you spend about 2 minutes, stop the video, spend about 2 minutes and try to understand what is going to be the effect, and probably after you switch on we will again see what happens if we replace this brace with this brace in the previous program. So, please pause for about 2 minutes, try to understand what will be the result, then we will run the program again. I hope you did that. So, let us try to make the small change to that program, okay, whereby I replace this brace with this brace. What is happening is, so I am just change the braces like this, I am running this program. Now, if you look at this, the difference between the previous execution and the current execution, since I put a curly brace and then once I put a curly brace, the whole thing becomes a block. Okay. So, it becomes a block of code, and since it is only a block of code, I am able to get the value of the variable, okay, the inner variable also inside the code, because essentially it is only a single process that is running and it is a single shell program. Whereas, when I just change it to the curved braces, we actually see that a new process is created, or and because of which the variable is not getting exported and the parent program is not able to see the value of the inner variable. So, this is the major difference between using block. So, that is exactly what we have also defined here. So, we have just explained it like that, stating that. So, if you look at this, the code inside the parenthesis will run as a separate process, okay, whereas if you put this kind of curly brace, then it becomes a command block, and obviously since you have to spawn a new process, okay, it is slightly less efficient than the command block. So, what we will do is we will now go forward to a new command that we can use. This is slightly different from what we have been using in the previous stage. Okay. So, eval is a command that lets you execute the same command, the command twice. Okay. So, why do we need this? We already know that you can skip expansion of variables or commands just by putting this single quote. Okay. Let us demonstrate that with an example. Okay. So, I will go ahead and say list files is equal to, let me put it as ls and then I will say more, okay, and I say echo dollar list files. So, it essentially tells you that echo dollar list files. Now, suppose I just want to run this, let us see what happens if I want to run this. Okay. So, I say dollar list files. Okay. So, what happens is that this variable gets expanded as ls, okay, command, and then what happens with the ls command is that the ls commands expect some kind of an argument, okay, but the argument that you are passing is a pipe symbol, okay, and then it has got another argument called more. So, because of which the command does not know what to do. So, the ls says that, okay, there is no such directory called pipe and then there is no such directory called more. So, what we can do now is that, now suppose I want to run this ls command, what I will do is I will just say eval dollar list files. So, if you look at this, when I say eval dollar list files, so what exactly is happening is that if I say this list file, so if I say list files is equal to ls more, and when I say echo this is list files with a single quote, so what happens is that it does not expand. So, actually it should be dollar. So, let me now make it, so there is an error here. So, what I should do is I should say dollar. So, when I say dollar and then execute this, let us try to execute this in the previous slide. Okay. So, what we will try to do is we will try to execute this command. So, I say echo and I put dollar list files. Okay. So, as I told you, it just echoes ls and then space pipe symbol space more. Now, if I put it within single quote, if you look at this, then the expansion is also ignored, okay, whereas if I put within double quotes, then the value gets expanded. Okay. So, if I put within double quotes, the value gets expanded. So, essentially if you put something within single quotes, it tells you that ignore that, okay, whatever is within the single quote. So, do not expand or do anything here. Now, this eval command exactly does the opposite. It actually executes it twice. Okay. So, what had happened with this eval command is that, so if you remember we put an eval dollar list files. So, what happened was that at the first step of evaluation, the dollar list files was expanded. Then after the dollar list files was expanded, then the command itself was run. So, you are trying to execute this program twice. The first level of execution happens when this dollar list files itself is expanded, and the second level of execution happens when the command, that is nothing but ls pipe it to more, itself again gets run. So, the program gets run 2 times. Now, why is this feature provided? Okay. So, this can be used to write some sort of a programs that modify themselves, okay, after the first execution. So, there are situations where you have to modify certain requirements during the execution of the program. Say I have 2 choices of execution and I want to execute one choice after looking at what has happened in the result, okay, of a previous execution. So, in such circumstances we can use this eval command.